Hello, I'm Arnaud FENIOUX. For those who don't know me, I'm working at FENIOUX since 1 year now as a network engineer. And today I will talk about the project we worked with RIP. So it's a RIP Atlas and the routing information services. So let's begin with RIS. So FENIOUX provided two servers, as you can see on the picture, that are currently hosted in TH2 in Paris. So what is the RIS collector? The aim is to establish BGP session with peers on FENIOUX and collect and store the BGP updates to make some statistics that you can see on stat.ripe.net. Like for example, the routing status for AS, the list of prefixed unknown by an AS, and other information like the neighboring ASN, some looking glass, and all those things I will show you right now. So this is how it looks like. At the top, you can search, for example, for an AS, and you can see where the AS is located and if it's correctly seen on the internet. If you go to the routing tab, you can see, for example, here's the number of prefix announced by this AS, and you can also look if the prefix are correctly seen by all the peers pairing with the RIS collector. Can be very useful. Another very interesting tool is BGPlay. The red dot is the origin AS, and you can see the adjacency and also have an historic on all the update and the topology change. It's used, for example, by the French National Agency, the ANSI, and they made some study on the data collected by the RIS. And in 2014, they were looking at 1,500 franchises, and they analyzed more than 7 million BGP messages and could find more than 300 abnormal conflicts. That means usurpation, hijack, and most of time due to misconfiguration. I've put the link below, so if you're interested, you can watch the video explaining this in details. I will now talk a bit about the RIP Atlas. So the RIS collector was only regarding BGP and the data plane. Oh, it was the control plane. No, it's the data plane, sorry. So RIP Atlas, at FENIOUX we're hosting an anchor. We have a web page where you can find some details about it. And the aim is to program some check or on the probe or on the anchor. And you can do some ping, traceroute, DNS, SSL, HTTP, and NTTP check. So here you are really checking how is acting the data plane. And you can also add some options like the address family, IPv4, IPv6, or the number of packets, and a lot of other interesting options. So there is a very well done interface on atlas.ripe.net. You can create an account and ask for credit. And it's really easy to add some measure. For example, here, I try to make a ping, and I can define the target, the interval between the checks, and with all this information, the RIP is calculating the total amount of credit I am spending by this measure. And if I'm using too many credits, and I can ask for more credits. There is a link, claim 1 million credits here. Once you have defined your measurement, you can also choose your probe. By default, there are 50 probes that are chosen almost randomly, but not fully randomly worldwide. You can define some geographical zone or probes in some defined ASN. That's really useful if you want to only check probes that are located in France, that we will show you right after with Emile. And you can also include some tags. I have provided a list of tags available. For example, if you are doing IPv6 test toward your infrastructure, you probably want to only use probes that have IPv6 correctly working. So here you can see the tags for that. An example of using these probes is you can have probes around the world toward your infrastructure for almost nothing. And you can fetch this data and parse with a special URL. Once you have created your measurement, you can get this data with the measurement ID. And you can easily parse the JSON and ask for example, if I made the check for 50 probes, I can say if I have more than 2 probes that are not correctly answering, I can have an alert. As you can see in the example, here I only have 1 probe that didn't answer correctly, so the global alert string is set to false, but if there would be more than 1 probe, then it would be switched to true. So you can easily use it in your Nagios or Ishinga to match this string and trigger some alarm on your monitoring system. That's a very useful thing because you can make some probes all around the world for almost free. Here is below the link of the RIP Labs article that is also explaining this. Another very interesting tutorial or what you can do with the RIP Atlas is a presentation that Stefan Bortsmeyer made during the AFNIC days a few weeks ago. So I've put the link. It's a 2-hour video, but you can see a lot of examples on how you can use it on your infrastructure. That's all for me. I will let the floor to Emile that will show you and explain all the data we could collect and analyze on FENIOUX.
Merci. Is there a laser pointer here? Yeah, there's a laser pointer. Hi, I'm Emile. I'm from the RIP NCC. I just came here from the Netherlands, not for tax reasons, by the way. So I'm going to talk a little bit about RIP Atlas and RIS from the RIP NCC view and what we've been doing together with FENIOUX. First, RIP RIS, control plane data. I think my slides have it the right way around. Yay. So RIS, route collector system. So we look at the control plane. We collect info from the community by the community, or for the community by the community. And this is data that you can download from RIS, and it's a lot of what powers RIPE-stat, and there's the URL there. Current status is we're doing an overhaul of this system. The old system was Quagga-based. We had 11 route collectors, but they were filling up. Was scaling issues. It's still our production service, but we're moving towards a new system, is XBGP based. We have 3 route collectors up, JSON based, which with MRT files for backward compatibility. But most importantly, there's plenty of room for growth there. Currently in beta stage, but progressing really well. There's an interesting presentation at the last RIPE meeting from my colleague Colin Petrie, who's been doing a lot of this work. And I recommend, if you're interested into this type of thing, to check that out or go talk with Colin at a next RIPE meeting if you want to know the nitty-gritty. So this is basically what it looks like. Peers, there's XBGP processes, and this all scales very nicely. There's local queuing. If something doesn't work here, it doesn't affect here. Then it comes back to us, and then we can deliver that data to everybody. This is sort of what it looks like on the sort of consumer side of things. There's still MRT files being created. Data goes into RIPE-stat, but this is really interesting and new. It's basically the ability to give you a live stream, or a live stream actually, of BGP data. So you can develop applications, alerting, whatever that this architecture enables. So here's where FranceIX comes into the picture. One of these new cool RRCs is RRC21 at FranceIX. We have 11 peers up in V4 and V6. And our engineers were really excited specifically about FranceIX for the ability to be actually at multiple lands at the same time. So we have Paris and Marseille. And there's actually, with the setup that's at FranceIX, there's the potential to partner with, or to connect up to the partner IXPs in the future. Use case here. And this is all from a preview of how it looks like in RIPEstat, because these three are the new RRCs, which you won't see in the production version, so don't go to stat.ripe.net to expect this. But these are the new three. And what you can see, for instance, is your prefix or your AS consistently visible across all of these. As you can see, there's a 91% here, and this is actually for AS333, which is the RIPE NCC itself. So apparently we have one peer at FranceIX, which you can actually see here, doesn't see us in V6. So that's something we reported to our ops people who are in the process of fixing this. There's the URL for this widget. Another one, AS path length. Here you see all the route collectors. I circled FranceIX. This will actually get a real proper name. Now it just says test something. As you can see, the FranceIX AS is a very, very short path and longer path for the rest. The same for yellow. And if I just look at contents, well, it's pretty much round for Google, Netflix, Akamai. Actually, Akamai, we get some feeds in some places, so the distance can be 0 there. So this is ready, almost ready for production, but we're already taking peers. So come peer with us. Just submit here. FranceIX is in the list that you can select here, so that's pretty cool. So from the research side of things, and from the data collection and processing part, in the past we've asked people to give us full feeds, like the feed you would give to if you were giving RIS transit. But a lot of peers actually give us their peering feeds, not their peer routes or the transit routes, just their customer code, so their own prefixes, their customers' prefixes, etc., etc. So as a result, we have this heterogeneity. It's a mix of things, and if you want to consume data from this system or analyze it, makes it a bit hard. Like, which ones do I pick? So we had a visit from, we have visiting researchers at the RIPE NCC from time to time. Randy Bush actually came visit us 2 weeks ago. Result of, talked about this problem a little bit, and the result is an internet draft on how to potentially fix this, how to make this easier for people. Draft basically goes into defining a customer cone, external and internal routes. Customer cone being what you would give a peer. External is transit and peers. We don't want to know about your business relationships. We just want to know what the cone is. And internal routes, that's probably stuff that you shouldn't give to RIS anyways, but and you tag that with communities. And idea is that this makes these feeds a lot more useful on the data consumption side. So if people have ideas about that, it's in the grow area of the ITF. So that was RIS. Now RIPE Atlas. So that's data, plain data, not plain data, plain, but people have probably seen plenty of RIPE Atlas talks, and if somebody hasn't seen it, I can probably give it to this one person privately. This is a real interesting visualization by a colleague, Andreas Strikos, who actually, this is actually is a URL to an animation of how the network grew over time. So it's internet data plane measurements for the community. By the community, 8,600 probes online currently. Moving towards France, of course, I have to put this slide in. 755 probes active 2 days ago when I created this, probably 1 or 2 more right now. 9 RIP Atlas anchors, 123 ASNs covered. And if you're really good at counting, you'll notice 1 probe is missing here. It's there on Corsica. RIP Atlas at France IX, as Arnaud already mentioned, we have a RIP Atlas anchor. That's the URL. So one of the things you can do with these things is you can all monitor your network from the inside out. You own your network, but outside in is a little bit trickier. So that's what RIP Atlas enables basically. And actually Stefan wrote a nice RIP Labs article, came out yesterday, about how to use RIP Atlas anchors as points where you can ping to, stable points where you can ping to, because yeah, that's needed. It's real handy to have these available for you if you're debugging stuff. These anchors also have automatically scheduled measurements from other anchors. There's 144 anchors in total, and from normal probes. You can see all of that goodness on the map here. And these anchors earn credits. So to do RIP Atlas measurements, you need measurement credits, and these things actually gain credits. So the France IX anchor also has credits. So if you need credits, ask Arnaud here. It currently collects, if I understand correctly, it collects more credits than it gives out again. So that's another thing that France IX can do back to its community with this. So this is what I think is a really interesting use case for RIP Atlas, which I call the IXP country Jedi, because my kid loves Star Wars. So does local traffic stay local? That's like an IXP type question, right? Well, of course, RIP Atlas doesn't know about traffic. We don't measure traffic, but we know about path because we do trace routes. So what if we would just do trace routes from all of the RIP Atlas probes in a country to all of the RIP Atlas to all the other RIP Atlas probes in a country? So for France, you'd have to do this many trace routes. That's a lot of trace routes. I don't want to do that. So it becomes much easier. So let's not do that. Becomes much easier if you only select 2 per ASN, and then if you select a little bit of geographic diversity, for instance, take the probe closest to the capital of the country and the one furthest from the capital of the country, you'll get some geographic diversity as well. So that is only 23,000 trace routes. That's manageable, right? 2 questions I was really interested in is, do we see IXPs in the path, and do we see paths that go out of country? And do they need to be fixed? Is this a problem or not? So first question, do we see IXPs? So this is data for trace routes from France probes, 2 France probes, maximum 2 per AS. And I just tried to see if I saw the France IX peering lands. So 23,000, lost a couple of hundred trace routes. 27% we see France IX Paris. 1% France IX Marseille, and in V6 it's a little more in France RX Paris and a little less in Marseille. So we can actually do this. This is where it becomes a little bit more interesting, I think, because if you just put this stuff in a matrix, so this is all probes which are the sources, and this is probes which are the destinations, and I ordered them north to south, and here also north to south. So this is north to north probes, south to south probes, and this is only V4. As you can actually see, that's pretty nice coverage of France. A lot of stuff actually going through France IX, and here you see Marseille in the south actually. But what I found really interesting is that here in the south to south, there's still people using or where we see the Paris peering land. So there's an opportunity for these people to actually move towards Marseille. Then this is an interlude to get to how do we figure out if paths are out of country or not. We have an IP geolocation database for infrastructure. If you want to do IP geolocation, MaxMind works pretty well for eyeballs, not for infrastructure. So what we're doing here is crowdsourcing the geolocation of internet infrastructure. So basically this is a database where experts, you, report where you think infrastructure, IP, or hosting is. And a couple of people here in the room have been really instrumental in helping out populate the database. Martin Levy, Arnaud, they were a couple of the founding people helping out with this effort. I'm really grateful for that. This is integrated with RIP Atlas trace routes. So if you do trace routes in RIP Atlas, there's a tab there where you can actually see what do my trace routes look like on the map, which is powered by this. And actually, researchers even say this performs better than any other geolocation services. So if we use this database, map stuff, map the trace routes to locations, what percentage of path from France to France do we see going out of country? IPv4, 10%. IPv6, 18%. Interesting list of countries. Well, here it becomes a little, well, you probably don't want that. Japan. So it brings me to causes for out-of-country path, because you actually want to know, is this a problem or not? Two of these probes are in CERN, and they're less than 100 meters from the Swiss border. So I don't forgive them for not trying to keep their traffic or their path within France. A Danish company in Paris, some stuff moves up to Copenhagen. But this one I find really interesting. There's a probe behind a Lisp. It's a Lisp testbed. But this is what you get from some probes if you trace route towards that probe. So Brest goes to Paris, goes to London, goes to Atlanta, Houston, Los Angeles, Tokyo, actually, it's, oh yeah, Tokyo, and then goes back to Los Angeles and then back to Paris. So it circles the world more than halfway around and then back. So I don't know much about this, but this is probably not how it was intended. But it also shows how if the internet was a person, it's really trying hard to get a packet delivered. So that's really cool, actually. So what you can also do if you have geolocations is put this stuff on a map. So don't go to this URL unless you want to crash your browser. Chrome and a decent MacBook will actually be able to render this, but you're warned. So if you put this on a map, you'll get a nice spider web across France like this. The spider web shape is probably due to the probe selection because I selected close to Paris and furthest away from Paris. But you can also see a couple of interesting off-country places like London, Amsterdam, Frankfurt. These are potentially things that you can look into and see if you can keep that traffic or these paths in country. Especially if things are really, really latency sensitive, or since Snowden, there's more emphasis on cross-border traffic. That's another reason I've heard people mention for being more observant of this type of stuff. So putting IXPs and out of country together, so does it go through an IXP? And in this case, I'm only looking at France IX, by the way. I'm just ignoring other IXPs in France for now, So does it go through France IX or not, versus does it stay in country or not? And you can actually, and it's color coded, so green is suggestively best. It's through the IXP, stays in country. Orange is not through IXP but stays in country, so it's private interconnects or another IXP. Blue is through an IXP but goes out of country, and there's actually a line here, but that's actually that list box, that strange list box. And red is no IXP and also out of country. And these are, specifically, these are the things that people might want to look into if your network is one of these. And actually this is an interactive visualization, which I cannot do here. But this is the URL for this. So if you hover over one of these cells, you'll actually see a traceroute output, which actually tells you the path that was measured with traceroute. If you do that, you'll probably notice I'm a crappy UI programmer, so if you know UI programmers that dig this type of stuff, help here would be really appreciated. The other thing that you can also do is, of course, map the IP addresses from traceroutes to ASs and just make a nice graph of that. Here you see France IX and France IX Marseille, and you can kind of see how interconnected they are. There's a nice group of like the very large transit providers here, and they cling together, which suggests that a lot of traffic actually goes from French network, large transit provider, other large transit provider back to French networks, and that's another potential cost money on both sides probably, which would also be interesting to look into. So action points, network operators. You can explore these graphs. You can actually see, is your network in there, and are there examples of stuff in here that's important for you latency-wise, or it really makes strange curves, and see who you need to talk to improve this. For an IXP, you can, of course, bring these people together and use this to encourage them to peer locally. So it's the ops that need to peer, not the IXP and the operator. This code is available on GitHub if you want to play with it. You need plenty of RIP Atlas credits, but if you have, please improve on it, use it. If you have feature requests for this type of stuff, for instance, I want to have ability to look up my own AS and stuff like that, just talk with me. I have some backup slides, but if you're interested in other stuff, just look at the slide set. So that's it for me. Questions?
Maybe if I talk really loud. Okay. I was wondering, what's the amount of big cloud players that are willing to play with Atlas? Because when you have a problem in a public cloud, for instance, you're like, okay, I'm doing transports to the cloud, it works, but I do not have the other way around. And it's usually a big black box, and I don't know where my traffic goes. And when I ask them, they're telling me everything is right, and it's probably my internet that sucks, or anything like that. So, do you have any big players that want to play with Atlas?
Yeah, we are eyeball heavy, of course. I mean, these little devices are much easier to install. We get a little bit more on content type side, or data. Let's call it data center side with the anchors. But indeed, that's a part where we're not as well covered as you might want. There are ideas to have this as a VM that might solve it for some particular cloud type services. Yeah, but if you have ideas on how to improve it, then we're all ears. Yeah.
Do you see prefix more specific than /24 I would like to know if you see prefix, IPv4 prefix more specific than /24 on RIS collector.
On actually, you're referring to this RIP Labs article that, yeah, I had it in backup slides. We do see longer than /24s actually. Actually, at France IX, the RIP collector here, we see two networks that, so we do announce from the RIP NCC, we do announce a 24, a 25, and a 28 to be able to, and this is from Aaron's address space that is specifically reserved for this type of thing, and their policy explicitly states you can get blocks from 24s to 28. So we announced them to test, and actually test results say it's 20–30% of RIS and of Atlas autonomous systems see these. And we also see them a little bit in France IX. So not useful to be globally routable yet. We don't know.
Okay.
Hi.
Just to let you know that in RIS, so it's things in Reunion, you already have a lot of /25, 28, and /30 on the exchange, and we can't see the prefix elsewhere than the exchange, so you have to accept /25. So it's back in far away from here. It's a Reunion. It's near Mauritius, so you have a Sphinx exchange.
Yes, indeed, it is coffee time. Thank you. For the validation of the accounts, we were requiring 60 votes to reach the quorum. I remind that the quorum for France IX is 25% of participants.
La première réponse, c'est la bonne. Il y a deux adresses IP. Il y en a 21 qui renvoient NX domain, c'est-à-dire qui disent que ce nom n'existe pas. 31 serveur failure. Les deux au milieu avec l'adresse 146, 112.